Welcome to this training module on ZipLine Connector Systems, FCI. This training module introduces FCI's ZipLine Connector System and its key features. The ZipLine Connector System uses the proven shieldless technology pioneered with FCI AirMax VS connectors to deliver low insertion loss and crosstalk at data rates up to 12.5 gigabits per second. By reducing the column pitch and increasing the pin count per column, ZipLine connectors are the first high-performance backplane connectors to achieve signal density of 84.6 differential pairs per linear inch of board edge. Not only does the ZipLine connector system achieve this significant milestone in linear signal density, but it does so in a smaller package. As the graphic shows, using ZipLine connectors in your design provides more space for components, more space for cooling airflow, and more space for signal routing. Like FCI's popular AirMax VS connector, the ZipLine connector allows for flexible pin assignments and eliminates the costly and heavy shields between columns of terminals. Since proximity to ground shields is not a requirement to achieve high performance, it is also possible to vary the column pitch to accommodate unique trace routing patterns. ZipLine connectors perform the Telcordia central office requirements and provide 2 points of contact at the mating interface for reliability. Compatibility with hard metric design practice allows the designer to utilize auxiliary components such as guides, power, and even AirMax VS and Millipack's hard metric signal modules on the same board edge as ZipLine connectors. No PCB cutouts are necessary. Header options include 2 or 4 wall housings. The 2-wall shroud allows ZipLine modules to be stacked end-to-end with no breaks in the PCB hole pattern. The 4-wall header provides additional protection for header contacts when a module is used alone or at the end of a row of headers. ZipLine connectors are the highest density backplane connector with press-fit termination. A stainless steel organizer provides a strong ground structure around the outside of the right-angle connector module. This sturdy module can be pressed onto boards using simple flat rock tooling. Current ZipLine connectors are designed to terminate to the same size plated through holes as AirMax VS connectors. FCI offers a variety of power and guide modules that complement the ZipLine connector system. Power options start with a 6-pair power IMLA that can be included as part of the ZipLine signal module. A power insert molded lead frame assembly, or IMLA, in this configuration handles 6 amps per contact with 6 contacts per IMLA. For higher current applications or those that require sequential mating capability, hard metric power modules provide options for 20 to 40 amps maximum per contact, or HCI power modules with capacity for up to 82 amps per contact. Some HCI modules also include an integral plastic guide blade. Other guidance systems employ either a metal blade guide or a keyed round pin guide. The round pin system is capable of 8 keying positions and also offers an optional ESD discharge contact built into the guide receptacle. Shown here is an example with two 6-pair power IMLAs integrated in a ZipLine connector module to provide an assembly that handles both signals and power. A signal power IMLA can handle 36 amperes, but the use of multiple power IMLAs in the same module requires derating. Sequential mating of ground, power, and signal contacts is often needed when daughter cards are plugged into a backplane. This chart shows the normal mating pin wipe lengths for various ZipLine, AirMax VS, power, and guide modules that may be used together in an application. FCI ZipLine signal connector modules include 6-pair connectors in both 12 and 16 column variations on 1.8 mm centers. In addition to traditional backplane configurations, some customers have asked for an orthogonal interface between opposite sides of a midplane. FCI has responded with a header that facilitates this type of interconnect. Note that the ZipLine right-angle receptacle module can be used in both backplane and orthogonal midplane applications. A recent addition to the FCI ZipLine connector product family is a right-angle header. This header enables coplanar mating of boards, which can be useful for extender cards, low-profile assemblies, and in direct attach rear plug-in card applications. The standard ZipLine 6-pair 12 IMLA backplane connector consists of a housing loaded with header contact IMLAs. Both standard and orthogonal headers have identical mating interfaces. The only difference between the headers is the configuration of the press-fit tails that terminate to the printed circuit board. The housing controls the separation of the IMLA columns. This slide shows ZipLine orthogonal midplane connectors appear in a typical application. In its densest form, the ZipLine connector provides 72 orthogonal pairs per midplane crossover. The headers are pressed into shared via holes on a minimum 3.5 mm thick midplane. Similar to what was presented earlier for backplane connectors, you can see that ZipLine orthogonal connectors provide the high density with one of the small print footprints. ZipLine orthogonal connectors provide more room for components, traces, and airflow. Here shows a representation of the signal pattern on an orthogonal midplane. FCI's data shows that under worst-case asynchronous conditions, near-end and far-end crosstalk values are very low. This slide shows two items of interest. First, it highlights the different tail patterns for the standard backplane and orthogonal midplane header configurations. It also demonstrates that IMLAs can be selectively loaded into the housing. In these examples, spacing adjacent columns on 3.6 mm centers. Wider column spacing may be desirable in designs where trace routing and PCB layer count are concerns and density is not. ZipLine connectors had 0 errors when tested to IEEE 802.3 AP standards. FCI ZipLine connectors are fully compatible with the fastest silicon available today. Another advantage of the ZipLine connector system is that the intra-pair skew is practically zero. further enhancing high-speed performance. Trace routing for ZipLine connectors on 1.8 mm column pitch is achievable with 8 mm spaces and traces with 1 pair per printed circuit board layer. The drill size is the same as that used with FCI's proven AirMax VS connector systems. When IMLAs are populated in every other position, you can achieve 3 differential pairs per layer with 6 mm spaces and traces. ZipLine connector electrical performance is not impacted, though density is obviously decreased. This chart shows part numbers for FCI ZipLine connectors that are currently in mass production. Contact FCI for additional part numbers if required.